Good morning.
Good morning. Good morning.
Hi.
Good morning.
All right. Well, let's see. We got everyone there in Holbrook today.
Yes.
Looks like it. All right. And who are we missing in Joseph City?
I think everyone's here. They're just running a little late.
Okay. All right. So, do you guys? What time does your Let's see. Is this fourth period for you in Joseph City?
Yeah.
So, what time does third period end? Or is it because some of you are coming from seminary or?
Well, fourth period starts at 11, but we've got like stuff for a float happening right now, and there's people taking care of that. And Avery's usually the only one that's late because he
Okay.
talks to his girlfriend, but
All right. Well, he needs
there's
to quit.
people doing homecoming stuff.
He needs to quit doing that. All right. Well, let's. Okay. Well, let's talk about. So I So today we're going to go over section 2.3b, or the second part of 2.3. So you can get that out. We may also get to 2.4. All right. And then, but before we do that, I actually wanted to talk for a minute about the Talon Pre-Calculus Assessment Guideline. So I just want to talk a little bit about things about quizzes, tests, midterm, and the final. So I just kind of want to make sure that we're all on the same page as that. So anyway, so if I will post this, if anybody wants it, you don't have to write it down or whatever, but if you'd like a copy, you're welcome to do that, to have that. I'll happily do that. So I just want to go over my expectations so that you know that we're clear. All right. So number one, all tests and quizzes will be proctored outside of class time. The midterm and the final will be proctored during class time. So we will actually take, our regular class time instead of meeting. That's when we'll do our midterm and final. Personal use of cell phone and non-Moodle websites is strictly prohibited during any assessment. Discussion of assessment items with anyone other than Mr. Strong is strictly prohibited. Anyone found discussing assessment items will be given a 0 on the assessment. And I'll just tell you right now, if you got a 0 on the final exam, you're not going to pass the class, probably. All right, students will be given an hour to complete both attempts of a test or up to 3 quizzes, not both. Now, I know that, there were some issues yesterday with, I guess let me go through and then we'll talk about issues. Okay, students will generally be given at least 1 day to complete practice problems and ask questions before being assessed on that material. For example, a section or chapter finished on Tuesday will not be assessed the next day, okay, to make sure that you have time. Number 7, in the event of a scheduled disruption of the test time, athletics, for example, the student is to schedule a makeup time with the Talon aide and email Mr. Strong before the event, okay? You don't have to email me and say, look, I'm going to be gone with the volleyball team. Can I make it up? The answer is always going to be yes, okay? What you need to put in your email is say, I've talked to Mrs. Smith or I've talked to Miss Buckley, and I was wondering if I could make up my quizzes 1-7 and 1-8 and 2-1 on Thursday at 12 o'clock. Okay, and some of you are doing that, and I appreciate that, and so that's awesome. All right. In the event of an unscheduled disruption of test time, internet outage, for example, the talent aide will email Mr. Strong for additional time or reschedule the assessment. Okay? If there's something, there was one time where I had somebody in Winslow during a midterm exam, they had forgot to charge their little laptops. And so laptops were dying in the middle of their midterm. I mean, you can imagine the stress that those kids were going through, okay? Just know if there's a situation like that, or like the internet went out at Mogollon on the last calculus test or something, and so they lost like 15 minutes. And so you can, I know you can imagine the stress that those kids were going through. Just know that I will make that good. Well, I will either, if I know about it right away, I will extend the time, or give you a makeup session, makeup time. Okay, we'll figure it out. Okay, so don't think that I won't work that out. All right, because you have no control over that. Okay, if there is a problem with the assessment itself, and let me just say that all of the questions that I put on the quizzes and the tests have all been vetted. And what that means is that I've gone through them, or the department head's gone through them. And so hopefully we've worked out any issues. However, every time they update the Moodle, that some of the links are broken maybe, or, you know, if I put in a graph or something, and you're supposed to look at the graph and answer the question, then maybe the graph doesn't show up. Okay, and so last year it might have worked fine, but then this year there might be an issue. So that's a problem with the assessment itself. And so then the talent aide will email Mr. Strong for a correction or clarification. If this is not resolved during the assessment, and it is deemed to have caused the students to lose points, an alternative assessment will be provided, or the student will receive the points they should have earned. So if there's a problem with a question and you miss it because the graph wasn't there, or the link was broken or something, then either I will give you a new version of the quiz, or I'll just give you that point. Just say, hey, I'll fix it, you get the point. Okay? All right? And then please communicate other issues should they arise. Okay? Now, best practices to succeed on my assessments. Number one, do practice problems in the book. You will not have time to figure out how to do every problem if you rely on your memory of how we did that type of problem in class. Okay? I've had a student in the past say, Mr. Strong, I am running out of time on all these quizzes. And I said, show me the practice problems that you're doing from that section. And he's like, well, Mr. Strong, you're just such a great teacher that I just, take good notes in class and that's all I do. I don't really open my book at all. Okay? No wonder he wasn't able to finish the quizzes. Because if you're not doing the practice problems and you're running out of time on the quiz, that's on you. Okay? You need to have practice so that you know how to do the problems better. All right, the next one, start on time. Okay, so I did have a student that communicated to me that they were running out of time on the quizzes yesterday, and I checked and they started 15 minutes late. Okay, again, unless there's a reason why you're starting 15 minutes late, that's not acceptable. And you cannot use the idea that I ran out of time when you're starting 15 minutes late because of whatever. Now, if you have a legitimate issue, like, you get called to the principal's office or whatever. I mean, I know 1,000 things could happen that's out of your control. Then let me know. Communicate that with me. Okay? But if you're just messing around and then you run out of time, that's on you. All right? Also, keep track of how much time you have left. Okay? If you've got an hour, You've got to do these quizzes. You've got to keep up the pace. When you finish one, you need to start on the other one. It's not time to take, a 10-minute bathroom break and go get a drink of water or whatever. I mean, you've got to keep going. Submit your assessment before the time is up. Unanswered questions are counted wrong. So let's go on. Double check your answers. If you click the wrong answer, it's counted wrong. I can't do anything about that. Okay, I don't know what was in your brain when you click that. And then if you start an attempt, it will count. So if you only have 5 minutes to do your second attempt, and you have to redo 5 of them, if you have to redo all 5 of them, that's not enough time. Okay? And so it would be better for you to ask to reschedule the second attempt than to guess randomly. Okay? I would much rather do that. Now, so, as I was looking at the times and stuff from yesterday, there was, I see that, I had one student that got a 1 out of 5, spent 20 minutes, and then on their second attempt, they did it in 35 seconds and got a 5 out of 5. Now, what would you think is going on there if you were the teacher?
Cheating.
That's some cheating. That's evidence of cheating. Okay? So, if you're a lucky guesser, that's fine, but that's pretty much evidence of cheating. And so I want you to know that I know that. Okay? And so I would much rather that you got a B in my class and did it with integrity, or even a C. I mean, your integrity is worth more than 5 points on a quiz. I promise you that. Okay? Now, I've told you guys that I was one of these students that I wanted to get 100 on everything, and I get that. I mean, I want to be like that too, but it's not worth it. It's not worth it. Now, if you get to the end and you only have a few minutes left, don't start that second attempt. Okay? Don't even start it, because once you start it, that's your attempt. Okay? And I can't do anything about that. If you say, well, I only was able to do, 3 of the 5 or 2 of the 5, well, that's your attempt. See, what part of it is that I can't give you another attempt unless I give everyone another attempt. Okay? That's not fair for you to have a second shot and then a third shot and nobody else does. Okay? So just kind of keep that in mind. All right, so let's see. So what questions, comments, concerns? Okay, and let me just say that, think about as far as what you the disruptions. Well, somebody asked about, what's a legitimate excuse to be late or whatever to a quiz or whatever. Okay, the Talon schedule, it trumps the high school schedules. So if you are called in with student government or homecoming activities or whatever, you just have to say, not today. Today I have to start my quizzes at 11 o'clock, and and that's what you have to do. Homecoming goes all week long. If I had to deal with every student's schedule and every time they wanted to start, at different times, it would be a nightmare. I'd have to set up 50 different Moodle courses for pre-calculus. And I can't do that. So you've got to think about what the priority here is. Okay. All right. So, what other questions or suggestions? Now, if there's some suggestions that you have to make things run smoother, if you have some ideas, a lot of these things actually, the idea of limiting, where like in my calculus class, I gave them a test and a quiz one week, and they're like, that's too much. That's too much. All right. And so some of these things that, we've kind of adapted here. But do you guys have any questions, comments, concerns, suggestions? Okay. So just remember, if like, let's say that, that there's any issue at all where you feel like that your stress is through the roof because you feel so pinched on for whatever reason. There's a bad question, you can't read it, you're out of time or whatever, I want you to communicate that with me. Okay? I mean, we need to make progress through the course, and I can't just say we're only going to do one quiz a week because we would never get through it all. Okay? And really and truly, if in a perfect scenario, where if I was the teacher physically in the classroom with you guys, I'm one of those teachers that require homework every night. Okay? And so the class that I physically teach in Holbrook, they have homework every night. Now they don't have to turn it in every day, but they have something to do. Okay? So I guess what I'm saying is, remember, my expectation is that you're working on these problems. And so if you say, well, that's I don't have time to go through all this. Part of it is maybe you need more practice. So try that. Try doing that. For a college math class, for every hour inside a class, the expectation is you're spending 2 hours outside of class. Now, Wednesdays, I count that as toward so basically we have 3 hours inside of class. So I'm expecting 6 hours of work from you outside of class. So Wednesdays, when you do the quizzes, that's one of those 6. But I expect really another 5 hours of practice and work and that kind of thing. I mean, that's my expectation. So if you're not doing that, then try that and see if it makes a difference. Okay? All right. Okay, any other questions about quizzes or whatever? Or you feel free to email me if you have some suggestions or something like that. Okay? Now, anything anybody wants to say right now?
Thank you.
Oh, okay. You're welcome. I appreciate that. The other thing is that I usually do, if you're worried about, again, getting a 2 on a quiz is not a big deal. You can still get an A. But I know how some of you are really focused on your grades, because I was like that. And there will be at least 2 opportunities for extra credit at the end of the semester to pick that 2 up to a 5 or whatever. It's not so I don't want you to feel like, oh, it's gloom and doom. The other thing is that all the quizzes that we take all semester long are like 22% of your grade. Okay? So it's the idea of the quizzes is, I want you to do well, but it's also to help you practice for the test. And so I'm kind of glad that we're, working out some of these issues here, because next Wednesday, we need to take the test. So you don't want to be going into the test late and unprepared or whatever. Okay? All right. All right, well, let's go on to 2.3. We're on part 2 on the slope-intercept form of the line. Okay. All right. So the slope-intercept form of a line is y equals mx plus b, where m is the slope of the line and b is the y-intercept. So we talked about m a little bit on Tuesday. So if you have like y equals 2x minus 5, then the coefficient of x, the m, 2 here, is the slope. And then the y-intercept is negative 5. So if it has a negative, it goes with it. Okay, that's part of the b. All right, so if your equation is not solved for y, then you solve it for y to get the slope and the y-intercept. So in this case, we would subtract 2x and then divide everything by negative 3. And so then that would give us y equals 2/3 x minus 6. All right, so that's in slope-intercept form. So then the slope is the number in front of the x, the 2/3. And then the b is negative 6. Or that's the y-intercept, 0, negative 6. So then we can use this information then to graph. So you graph the y-intercept first, so 0, negative 6. And then the slope is 2/3. So from that point, you go up 2 over 3, up 2 over 3, up 2 over 3. As many times, you only need to do it once, but just connect the dots, extend the lines, add the little arrowheads. All right. So go ahead and try practice 2A. I'll leave this up for a minute so you can see the steps. So you want to find the slope, the y-intercept, and then graph it. All right, so Rebecca, what is this line and what's the slope-intercept form of this line?
This?
-2 and well the intercept and then
So-
the slope.
So I want the slope-intercept form. So y equals what?
Y equals 4 over 3x minus 2.
Okay. So y equals 4/3 x minus 2. Good. All right. So Anna, what's the slope?
4 over 3.
Good. And what's the y-intercept?
-2.
Excellent. All right. So then your graph should look like this. So the y-intercept, you graph that point first, -2. And then from that point, you go up 4 and over 3. Now, if your slope is negative, you go down and over. Okay? All right, any questions on any of that? All right. All right, we can also make use of the slope-intercept form to find the equation of a line. So, if I know the slope is 3 and the y-intercept is 7, then the equation of that line, you put the 3 in front of the x and the 7 for the constant, and so the equation of the line is y equals 3x plus 7. Or if you're given the slope-intercept form of the line and you're asked for m, then m is the number in front of the x, 3, and then the b is the constant, 7. Okay, so you can go either, however the question is asked. All right, so go ahead and do practice 2b, please. All right, so Rebecca, what's the equation of the line?
Is y equals negative 3/5 x plus 3.
Yep, that's it. Okay. And then the graph, you start up at the y-intercept at 3, and then if the slope is negative, you go down 3 and over 5 and get this second point. So you have the first point here, and then the second point here, and then connect the dots, extend the line. Any questions on that one?
If the whole fraction was negative, so it'd be like not just a -3, but then the 5 is negative, is there like a way to see that?
Yeah, see negative 3/5. That's the same thing as 3 over -5. Now, normally, if both the numerator and the denominator are negative, you just cancel and make it positive. But you could also, instead of like going down 3 and over 5, if you want to think of the negative in the denominator, then you could go up 3 and then to the left 5, and so you'd get that point there. So you'd still get the same line. But normally when we have a negative in the fraction, we put it with the numerator. But sometimes the way, like you might run out of room on the graph or something, and so it makes sense to do that. So that's okay, either way. All right? Thank you for that question. Any other questions? Okay. All right, next is the point slope form of the line. All right, so the point slope form of a line is y minus y1 equals m times x minus x1. And the m is the slope still. And the x1 and y1 are the point, the given point. So, whereas the x and the y without the subscripts are the variables, and you don't change those. But when you're given a point, you plug in the x and the y coordinates for x1 and y1 respectively. All right. So let's say we want to find the equation of the line that has this slope and this point. Okay? So we use the point slope formula and we say y minus the y coordinate 4 equals m times x minus the x coordinate 12. So you plug in the slope there and then the point for the x1 and the y1. Now, technically, that's it. You're done. You were asked to find an equation. You have an equation. But a lot of times they will ask you to write your answer in slope-intercept form. Okay? So what that means is that you have to get y by itself. So distribute the 5/6. So 5/6x minus and 5/6 times 12 is 10. And then add 4 to each side. And so then that's the answer in slope-intercept form. Okay? Now that's pretty much. All right. So if you look at practice 3A, it says find the equation in slope-intercept form. So it's saying that it wants the answer like this, in y equals mx plus b. All right. So go ahead and do practice 3A. All right, so Jay, what do you have? Oops.
Wait, do you want the simplified form or just the equation? Is the equation right?
Well, give me the equation first. Let's.
Okay, so I got y minus 5 equals 3 parenthesis x minus negative 2.
Good. Good. Okay, so now I want you to go ahead and simplify that, Jay, and then tell me what you get. So put it in the form y equals mx plus b, but this part is correct.
Okay, I think I got it.
Okay?
So is it y equals 3x plus 11?
Yes, it is. Okay? Great job, Jay. Any questions on that? All right. Okay, so we know that two distinct points are sufficient to determine the slope. So we can deduce the equation from just 2 points. All right, so step 1 is find the slope, and then step 2 use the point slope formula with either point. All right? So let's say we want to find the equation of the line that contains these 2 points. Okay? So step 1, find the slope. So like we did on Tuesday, the slope formula is the difference in the y's over the difference in the x's. So 12 minus 7 over 4 minus 5. So that's 5 over negative 1, which is negative 5. So that's the slope. All right, now we use the point slope formula, just like we did on the last one, and we can use either point. It actually will simplify the same. So y minus, okay, so I'm using this y1 equals the slope, negative 5, times x minus the x1, which is 5. And so then we get, distribute the negative 5, and we get negative 5x plus 25. Add the 7, and so we get y equals negative 5x plus 32. If we had used the other point, we would get the same final answer. Okay? All right, so go ahead and try practice 3B, please. All right, so Tara, what do you have for the slope?
I got 2.
2?
Yeah.
That is correct. Any questions on that? All right, so Jocelyn, what's the final answer then?
I used the first points, -3 and -2, and I got y equals 2x plus 4.
Y equals 2x plus 4 is correct. All right, any questions on that? Anybody want me to go through it? Again, if you use the other point, you'd still get the same final answer. I mean, this answer would be different if you used a different point. Okay, so you use -3, -2, and I used 1/6. Now, why did I use 1/6? Is because it has no negatives, and it's usually a little easier to deal with the less negatives. But it doesn't matter that much. All right. Okay, any questions on anything from 2.3? Okay, well, let's go on to 2.4. So 2.4 is kind of its own lesson here in this book, but oftentimes in a lot of books, it's actually in the same section as what we just did, because we're still talking about slope. But in particular, the slope of parallel and perpendicular lines. Okay? So let's see if we can just spoil the ending. All right? Does anyone know the relationship between the slopes of parallel lines?
They're the
They're
same.
same.
They're the same. And what about the relationship between the slopes of perpendicular lines?
They're the inverses of each other.
They're the inverse reciprocals of each other, or opposite reciprocals. So that's the big idea for this section. Okay? And so if you know that, really it's kind of the same thing as what we did in the last section. So parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Yes, question?
When you say opposite reciprocal, so I know the reciprocal is like it's flipped, right?
Yes.
Okay, so opposite, would that mean the opposite sign?
Yes. Yes.
Okay.
So if your original line has a slope of say 2/3, then a perpendicular line would have a slope of -3/2. So you'd flip the fraction and change the sign. Okay? Excellent question. Any other questions before we do some examples here? Okay, so slopes of parallel lines. Two non-vertical lines with slopes M1 and M2 are parallel. And then IFF, that means if and only if. M1 equals M2. So their slopes are equal. All right, so this says find the equations for two lines parallel to this. Y equals -1/2 x minus 173. Okay, well, we don't care about the -173 here. All we care about is what's the slope here. So the slope is -1/2. So the two lines parallel to that have to have the -1/2 x and then plus or minus anything. So +2 +2,000,001. Okay, those would be parallel lines. Okay. Now, if the line is not in slope-intercept form, then you have to put it in slope-intercept form to get the slope. So here we subtract the 2x and divide by -7. And so really all I care about is 2/7 x. So the slope is 2/7. This 92.4 divided by -7, I don't even care what that is. Because to find lines that are parallel to it, I don't need that. And so I'm just lazy, so I don't even work that out. So the slope here is 2/7. So the slope of lines that I want are 2/7. So y equals 2/7 x plus 40, y equals 2/7 x plus 55, or whatever numbers you wanted there for the y-intercepts. All right? Any questions on that? All right, let's go ahead and try practice 1A, both part 1 and part 2. All right, so Naomi, what do you have for the first one?
Y equals -2/3 x minus 33, and y equals -2/3 x plus 49.
Good. Okay, so whatever You can have anything you want for the y-intercept, including a Google. Anybody know what a Google is?
It's a 1 with 100 zeros after it.
One with 100 zeros. Do you know how it got its name? So this is before the search engine. A guy was actually going to a math conference, and he was trying to figure out a name for this. And so he had like I think a 4-year-old daughter, and he said, "Honey, what's the biggest number that you can think of?" And she's like, "A Google." So that's where we got the name. All right. All right. So, all right, let's go to the next one. All right, Serena, give me 2 lines that are parallel to that one.
It is on y equals 5x plus 32 and y plus 5x. Subtract 1.
Okay, good. All right. So y equals 5x plus or minus anything will work there. Okay, any questions on that? Okay, usually when we want to find an equation of the line, we use the point slope formula. So, if ever a question says, find the equation of the line that blah, 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 blah. Okay, this is what I want you to think of. The point slope formula. Whenever it says find an equation of the line, let that be your go-to thought, is to use that formula. Okay? So, this says find the equation. So, right then, you're going to think this. In slope-intercept form, so that means my answer has to be y equals mx plus b, which is parallel to y equals 3x plus 5 equals 23, and which passes through the point negative 2, 1. Okay, so in doing this, the point slope formula, okay, it's just like when we, in the last section when we had 2 points, what you want to do is find the slope first, then plug it into the formula, okay? So we have a point, but we need to find the slope. So we use the fact that the line I want is parallel to that line. So I have to find the slope of that line. So to do that, I solve it for y, and I get y equals negative 3/5 x plus, I don't care, okay? So all I would need from that is the slope is negative 3/5. And then the point that I'm given, negative 2, 1. And so then I'll put that in there, and I'll get, let's just do it right here. So I do y. So y minus the y coordinate, 1, equals m, negative 3/5, times x minus the x coordinate, which is negative 2. Okay? Now, I want to put the answer in slope-intercept form, so I need to simplify. So first, I'm going to distribute the negative 3/5. So I get negative 3/5 x, and then this is going to be plus 2, so that'll be minus 6/5. So negative 3 times 2, negative 6/5. All right, now I'm going to add 1 to each side. So I'll get, so if I add 1 over here, that's the same thing as adding 5/5 is equal to 1. So then I get y equals negative 3/5 x, and then negative 6/5 plus 5/5 is negative 1/5. All right, so go ahead and try practice 1B.
That's the same problem that you just did.
What? Are you serious? That's distressing. Yeah, I just take away all your fun here. What the heck? That's not cool. So this is practice too. Sorry. Okay. Yep. Dang it. All right, so did you write that down? Anybody need to see it again? All right. Okay, so we can also use the knowledge that parallel lines have the same slope to answer questions based on geometry. So, what do I mean by that? Well, if the question says, are these parallel? Or does this form a parallelogram? Okay. So let's look at this. So, let's just do look at the practice problem. It says determine if the quadrilateral with the vertices -4, 2, 3, 4, 1, 1, and 2, 3 is a parallelogram using slopes. Now, unfortunately, you can't just, if you graph it and it looks like a parallelogram, that's not good enough. Okay? You actually have to calculate the slopes. Okay? So what you do is, as you graph it, you're going to have to calculate the slope of each side. Okay? So go ahead and do that. So you can, so you have 4 slopes to calculate. If the opposite sides have the same slope, then it's a parallelogram. If not, then it's not. Okay? All right, so Jocelyn, do you have any of the slopes computed?
No, not yet. I was graphing it.
Okay. All right, does anyone have any of the slopes computed? All right, go ahead and tell me what you have.
Okay, well, let's see, I think I have a -2, and then another -2, and then a 3/4, I think.
No, it's not going to be -2. So look, I'm going to just stop right there, and I want you to do this problem, have it done before class on Monday. So you have to calculate the slopes of each side